we always make sure we have a stiff and stable frame. That's very important. You don't want your robot falling apart or shaking or bending out of place when you're in the field and contacting other robots. Maneuverability, that's also really important. Some years more than others, but some things you want to think about. If you have a 6-wheel tank drive robot like ours, what we've done is we've added a rocker to our robot. So what that means is we increase this wheel's diameter so that it acts as a fulcrum. So that allows the robot to turn easier. And if you have another thing you can do is add Omni wheels. On that robot over there, we use Omni wheels in the corner so it can turn easy. If there's a year or a game where maneuverability and going anywhere is really, really important, you might do a holonomic drive where you have 4 Omni wheels at angles. All this is part of that game analysis. You want to keep those things in mind when you're building your drive. You also want to have the ability to go where you want to or need to go during the match. So, for example, during Ring It Up, pushing was really important because there was a very small scoring area. Just pretty much in front of the rack and the dispenser was where you scored. So being able to push other robots out of the way was what you needed to do. In Bowled Over, it was a big field and you could go lots of places. So if you could drive around another robot, that was a real advantage. Going the right speed, that's kind of the same thing. It was a lot better to go fast in Bowled Over, but in Ring It Up, if you look during the finals, most of the robots were these slow tank-style robots. And then finally, once again, you always want to practice driving before the tournament and be prepared to drive in all parts of the field. We really saw this in Ring It Up. We would partner with the team, and they might have a great robot, but during practice, they'd only practice doing on the side of the rack next to where they drive. They had no practice driving on the other side, so if for some reason they had to end up going there, they were just missing rings or they were having trouble landing them. So as part of what we tried to be that team that would go anywhere. So we practiced so we could go both sides of the rack, do autonomous anywhere. So practice before a tournament, it's always important. You don't go to soccer tournaments, just never play soccer.
I'd like to throw one other thing into there. When you're doing your drive practice, imagine the other 3 robots on the field. In practice, in general, it's just one robot. So you have the entire field to yourself. I mean, that's good to start, but then you need to start thinking about, okay, what am I going to have to do to avoid other robots? Where are they going to be? What are they going to be doing?
Something we did for that, we built a small robot, and its whole purpose, it couldn't score, it was a really lightweight frame. Its whole purpose was to just get in the way. So we used that to simulate a small robot or just a robot getting in the way of the rack. So then our drive team had practice maneuvering around that or pushing out of the way.
Okay, just other design things that we go by. Isolate your motors from impacts. So instead of either directly putting wheels on the motors or using a motor to a gear and then a gear to a wheel, we use chain instead. This way the motors don't feel every bump that you go over in the field. And we found that you can break gearboxes and mess up motors doing that. So this way, whenever we go over a bump in the field, our motors are isolated by the chain. When you hit a wall, your robot should spin out rather than stall your motors. So one thing we always do at the start of or after we've designed a robot is we'll hold it back or we'll run it into a wall and make sure that it can spin its wheels. Otherwise, if you run into another robot or you run into a wall, you might burn out motors because you don't know that your motors are stalled.
This goes back to, I believe it was your question. So on our drive training, this is where this really comes in, is we always make sure our wheels will slip before they start.
Mechanical alignment. This is something that's really easy to demonstrate with our cups. So to pick up a ring, we saw some robots having to take a lot of time lining up underneath the dispenser, finding the ring, and making sure you're on the right place. We instead had tabs on the top of our cup. This way we just ran straight into the dispenser and then went straight up. And that's all we needed to do. That's all the alignment we'd ever do. We drove straight onto the dispenser, pushed all the rings back, and went straight back up and out. Program the nose. So for this year, it's like the heights on the rack. Instead of moving our ring cup up or down manually, instead instead we just had one button that would send it to a certain position. So on our robot we could push one button to go to the first level, one to go to the second level, or one to go to the third level, one to go back down, and so on and so forth. It made it a lot easier, so you were always right on track, and you were always it was always really easy on the drivers.
Yeah, it made it really simple for me to drive.
And then know the amount of motors you can use, and always make sure that you're not going over, but you use the limit. They're there for you to use. You can have 8 motors, 3 Lego motors, and 12 servos. So don't go over the limit, but try to use as much power as you can on your robot.
And use it where it makes sense.
Yeah.
We don't generally use all 12 servos. We just don't have that many things our robot needs to be able to do. That robot, we used all 8 DC motors, 1 Lego motor, and what, 2 servos?
3. So there's 1 Lego motor here moving this slide in and out. There's 6 motors, 3 on each side of the drivetrain. And then for our lift, we actually have 2 motors on a chain here. So that's so we can speed up how fast our lift goes up and down.
So that's one of the differences between these two, isn't it, that last point?
Yeah, so originally on that one, we had we only had 1 motor, but as we kept adding stuff to this ring cup, if you notice, this one has a lot more stuff on it than that one. It has weights, there are weight detectors, it has a servo, so it just got heavier. So to compensate for that, and so we could get where we wanted to be faster, we had this extra motor. We decided we didn't want to do a robot lift, so we used that, we just changed it to this one, so it can move up and down faster and have more power.